Hi there, my name's Adam Robbins. I'm the managing editor of cogsci and the head of science, and I'm here to talk to you as part of Chat Physics 2021 about how to implement cognitive science into your physics teaching. Now, this is going to be a bit whistle stop, so I apologize for that. Cognitive science has produced a number of outstanding ideas that science teachers can take advantage of, but unfortunately, we've only got a short amount of time here, so I'm not going to be rambling on. If you have any ideas or any theories or questions you want to ask, then cogsci is available either through the website or at cogsci on Twitter, and we'll be more than happy to have discussions with you about various questions you have. You can also find me at Mr. A. Robbins on Twitter. I'm more than happy to answer anything that you're curious about. Let's crack on then. If I can get computers to work. There we go. So why use cogsci techniques in physics, especially? Out of all the sciences, I think physics is the subject where cogsci techniques are most appropriate. Well, first of all, it's basically maths, isn't it? But the good stuff. And that's really important to us because cogsci studies often use maths. When you're doing an RCT, using maths means you get really easy quantitative data that you can analyze statistically because answers are either right or not, and there's no subjectivity in the marking. So physics has that aspect to it, which means we know that these ideas will be highly applicable. Physics also has a really good mix of two types of knowledge. Now it has the kind of disciplinary knowledge, the discrete factual knowledge of physics about what things are, but it also has the procedural knowledge, okay, this idea of if I get input A, what do I have to do? What process do I do to get output B that I desire? So in that case, classic examples would be graphing or would be calculation questions and aspects like that. There's a procedural part of it that can be mastered by anyone. Practice is kind of habitually built into physics as part of its ethos, the idea that you can get better if you practice at things, and you need to practice things multiple times to get really good at them. And this idea that confidence is everything in physics. So many people talk about why maybe girls aren't as good at physics as boys or something like that, and ignore the fact that maybe it's their confidence that is the thing that's most important. And I know as physics teachers, we're always keen to make sure students master things completely, and we prove to them they can get better with time, and that builds their confidence. Now, before I jump into the principles of cogsci, I just want to be clear about what I'm talking about when I'm talking about these principles. Principles are a broad thing, so we're going to talk about different principles of cogsci. And they're inclusive because they're about the human mind and the way it works, or the way we theorize it works. And so they could be applied to anything from physics teaching to painting into a certain degree. The practices we put into place in the classroom are the thing that you're probably more interested in. And some of them, unfortunately, are better than others. Personal choice comes into it. As a professional, you have to choose how to teach your class. I can't do that. Context is everything. I work as a head of science in a large coastal comprehensive on the South Coast with a huge proportionality of white working class students. So that informs my decisions. Maybe you work somewhere completely different, and that you're going to have different decisions based on those ideas. And I suppose that's fine. We have to take that level of personal responsibility. But a lot of the things I'm going to talk about today should work in all contexts because they've been tested on the human mind, and the human mind is relatively fixed as an idea. It hasn't really changed for a very, very long time. I need you to be aware of something called lethal mutations though. Lethal mutations will occur when good ideas get twisted and twisted and twisted by accident, people trying to emphasize the good points of them and actually make them into ineffective ones. So when you're looking at these principles, try to keep it simple, okay? Try not to overcomplicate things, try not to make it too flamboyant. Simple is best when it comes to cogsci techniques. It also involves the less work though. So here we go. These are the best things, and I'll give you a quick explanation of each one. So retrieval practice, this is the idea that the more you are asked to retrieve a piece, the more you are asked to retrieve a piece of information, the easier it is to retrieve. So a good example would be your phone number. Hard at the beginning, with a bit of practice gets better. We should be looking for students to try and retrieve essential information every lesson. Explaining things in small chunks, I'm pretty sure that's self-explanatory. break it down into small chunks so we don't overload the working memory, which can only hold about 5 to 7 pieces of information at any given time. Guidance fading is that process where you go from a fully worked example and explaining or modeling how to do something to partially completed examples, maybe just to some hints and tips, and then completely independent practice. If you have used Rosenstein's principles and instructions, this will overlap a lot. Bulk and spaced practice. Now, practice is everything in cogsci. You know, the more you do, the better you get. Bulk practice is doing a run of very similar questions in a row, so say 10 questions on F equals ma, and spaced practice is going back to calculations at relative points, maybe through part of the retrieval practice, to remind students and bring them back to mind and give them a chance to practice them so they don't forget them. This links in with the forgetting curve. Building on prior knowledge. So as a teacher, you have an expert schema or network of information. Everything is connected. And one of your jobs is to try and build a similar schema in the brains of our students. So figuring out what their prior knowledge needs to be, assessing whether they have that knowledge, and linking it explicitly to the things you're currently teaching them is really, really important. This can be built into the retrieval practice. Dual coding simply is an idea that text and words follow one channel in the brain and images, visuals, follow a different one. So presenting two of them side by side is an effective way of increasing the amount of information that students can take on at one time. Now, physicists do this a lot. I've never really known a competent physicist that when given a problem doesn't start drawing a simple diagram to try and lay things out. That's a good example of dual coding. Flow diagrams are a great example of dual coding. Having images everywhere as a kind of hieroglyphics instead of words is not necessarily effective. Sometimes it takes the context away and the students spend more time figuring out what the symbols mean than actually understanding the content. So we've got to be careful. We've got to train their minds on the things we want them thinking about. Dual coding can suffer from a lethal mutation quite a lot. Cutting out non-essential information so the students are thinking about the important thing. So if we want them to think about purity and melting points, we want to talk about substances that are not too sensational. We don't want to start talking about testing the purity of cocaine because they'll start thinking of cocaine. We want to start talking about simple things like wax and that, so they're understanding the concept of melting point analysis. I know that's a chemistry one, but I literally made that mistake just before Christmas, so I thought I'd drop it in. You know, we do make mistakes all the time. Narratives are really important. So your brain learns stories better than it learns abstract facts. And it's important to keep them in. I realize there's a conflict with the point above about non-essential information. So it's important that your story is well crafted and to the point and doesn't have too many details that would draw the student's attention away from the important information. The split attention effect occurs in resources when the text and the image are not joined together. So if you have a diagram, label the diagram with the relevant text. Don't have it in a key 1, 2, 3, 4 and then down the side, because every time a student has to move their eyes from one thing to the other, they will lose some of the information. And the goal-free approach is used for experts, so not at the beginning of topics when students are novices. And what it does is it provides a scenario but without a specific question, say a table of data or a graph, and asks the students to find the all the relevant information they can. And they'll provide more than one different piece of information. This allows them to apply lots of different parts of the topic to one area and show the links between these things, and that builds a richer schema of knowledge in their brain. So mandatory minimums, this is my idea of, if I was to say which things should someone focus on first, these are the ones I'd focus on. I've chosen these because they all can be done relatively easily. They don't need a lot of resourcing. They don't need a lot of restructuring, apart from maybe cutting out non-essential information. If your PowerPoints are quite visually stimulating, you may want to kind of trim them down, take out some of the words and things like this. But the other ones I've grayed out are the ones that I think are not as important. If you get those ones right, good, but they aren't going to make as big a difference as getting these ones right. And I think the good thing about these ones is they're quite easy to get right. So why is cogsci not used everywhere? Well, we do have a bit of a barrier with teacher training. It seems like they are slow to embrace some of the findings of cognitive science, and some institutions are resistant to it. Now, this is a very broad sweeping statement, but I'm only going on what I've heard and what I've seen. I'm sure there are some institutions that are amazing, but unfortunately, it seems like the PGCE, and therefore the training that I received, 17 years ago, and the training that's being received over the last few years, provides a bit of a deficit in this area. We often think of ourselves as when we were in school, and we get ourselves confused from when we were novices. And students as novices do not need the same thing that you need as someone with a great degree of education, university education, and things like this. And if we forget that, often means we end up going in the wrong direction. Maybe you already do it. Like, you could go down that list. You could say, yeah, I do all that. I do all that. I do all that. Well, that's really, really good. And you should be really proud of yourself. In my opinion, that means you're well on the way to make a huge difference for your students. But reflect, do you actually do it all the time, or do you just have one thing that does that? Does the idea of bulk and spaced practice permeate through your entire schemes of work? Or is it just when you do F equals MA, you do it there, and when you do Hooke's law, you do it there, but in between, there's nothing? Personal preferences, you might disagree with me. Fair enough. It's your life. You got to live it. Some people morally object to some of these ideas. They think that forcing a student to do 20 calculations is cruel, and things like that. And, fair game to them. I'm just glad they're not teaching my kids, I suppose, because I think I find those things work really, really well. And then another thing is 21st century skills. Students won't need knowledge, and that's quite frankly just rubbish. And I don't have time to go into that now, but if you want to, there's quite a lot of reading you can do on why 21st century skills are a load of nonsense, and how knowledge is the prerequisite for all skill application. So what does it mean if we're going to implement these things into our teaching then? Well, some of us, it's going to mean adjusting our practice. I know that's a journey I've been on in the last 3 or 4 years. It's not like I've always done these things. On my blog, I have a classic tales of terrible lessons I've taught to try and remind people that we're all a work in progress. And no one at cogsci is coming out here and saying they are the world's leading expert, apart from some of the members that are actually world leading experts in cognitive science, I suppose. It's going to be about refining over time. You can't just click a switch, although those mandatory minimums take very little changes to get right. It's about changing perspective, maybe changing the way you think, changing the way you plan, changing the way you approach a topic. And it's about experimenting a little bit, I suppose, and finding ways that work for you and your students, because your students will be slightly different to mine, and you may need a slightly different approach. And that's ignoring any kind of management and leadership issues about certain school belief structures and kind of mandatory approaches that need to be happening in certain schools. So cogsci is here to help you. This is the screen grab of our blog, cogsci@wordpress.com. We've got lots of different things on there. We've got blogs that we post. We've got free CPD modules that will teach you all about these aspects in detail. These things have been created by teachers and moderated by international experts in those fields. We've got resources, literally the entire specification covered, booklets with hundreds of questions in that you can have for free that people have made and shared. We run conferences, although not at the moment, obviously. We're launching a head of department zone to help people who are heads of department in science and want to share ideas. And we have things like the Go Bag and symposiums, which give you large areas. The Library of Explanations is a new area that we started a few months ago, and its aim is to create some of the best video resources and text resources about how to teach certain topics. We'd love to support you to make your teaching more effective for your students. We don't ask for anything in return. If you want to take part and become an active member, that's something we really welcome. And if you want to join the email group, you can go to the Who We Are bit of the site, and you can join up to 2,000 current teachers from around the world that commonly share information and ask questions and ask for help from each other through the email group. So that's it. I hope you found that useful. Please feel free to get in touch with me. I'm at Mr. A. Robbins on Twitter, or you can go to @cogsci, and we would love to talk about these things in further detail. Take care. Bye.